Water vapor accumulates in the atmosphere through evaporation. Primary sources of this water vapor include oceans, lakes, and vegetation. Evaporation is the process where liquid water transforms into a gaseous state. Solar energy drives the evaporation process by heating the Earth's surface. This heat provides the energy needed for water molecules to escape into the atmosphere. The transformation from liquid to gas increases the amount of water vapor in the air. Warm, moist air ascends into the atmosphere due to convection. Orographic lift, where air is forced upward by mountains, also causes air to rise. As air rises, it encounters lower atmospheric pressure, causing it to expand. The expansion of air leads to a decrease in its temperature, a process known as adiabatic cooling. This cooling is a critical step in the formation of clouds. Rising air cools as it ascends in the atmosphere. Water vapor in the air condenses into liquid droplets or ice crystals. Condensation requires condensation nuclei, such as dust or pollen. This condensation process leads to the formation of clouds. Cloud formation is influenced by altitude and atmospheric conditions. Different cloud types form at varying altitudes due to temperature and moisture levels. Common cloud types include cumulus, stratus, and cirrus, each with distinct characteristics. These cloud types form through different atmospheric processes, affecting their appearance and behavior. Collision coalescence is a key process in warm cloud precipitation formation. It involves small cloud droplets colliding with each other. Upon collision, these droplets merge, or coalesce, into larger droplets. This merging process continues as the droplets grow in size. Eventually, the droplets become heavy enough to fall as raindrops. Therefore, collision coalescence is a primary mechanism for raindrop growth in warm clouds. The Bergeron process occurs in cold clouds containing both ice crystals and supercooled water droplets. Supercooled water droplets are liquid water existing at temperatures below freezing. In this process, ice crystals grow by attracting water vapor from the surrounding air. This growth happens at the expense of the supercooled water droplets, which evaporate to supply the vapor. As ice crystals grow large enough, they begin to fall due to gravity. These ice crystals may fall as snow or ice pellets, or melt into rain if they pass through warmer air. Precipitation occurs when water droplets or ice crystals in clouds grow too heavy to remain suspended. These heavy droplets or crystals then fall from the clouds towards the Earth's surface. The form of precipitation depends on the atmospheric temperature profile. Common forms of precipitation include rain, snow, sleet, and hail. Rain forms when liquid water droplets fall to the ground. Snow, sleet, and hail involve frozen or partially frozen water. Thunderstorms develop from the rapid ascent of warm, moist air. This ascent occurs under unstable atmospheric conditions. The rising air creates strong updrafts within the developing storm. Simultaneously, downdrafts form as cooler air descends. These updrafts and downdrafts are key components of thunderstorm development. Single-cell thunderstorms are characterized by their relatively short lifespan. These thunderstorms typically develop in environments with minimal wind shear. The life cycle of a single-cell thunderstorm includes distinct stages of development. These stages progress from initial formation to maturity and eventual dissipation. Multi-cell thunderstorms are composed of multiple cells. Each cell within the storm is at a different stage of development. Multi-cell storms typically have a longer duration compared to single-cell storms. These storms are more likely to produce severe weather conditions. Supercell thunderstorms represent the most severe category of thunderstorms. A defining feature of supercells is the presence of a rotating updraft known as a mesocyclone. The mesocyclone is a column of rising air that rotates within the thunderstorm. This rotating updraft enhances the storm's intensity and longevity. Supercell thunderstorms are capable of producing extreme weather phenomena. These phenomena include tornadoes, large hail, and damaging winds. Updrafts and downdrafts are vertical air currents crucial to thunderstorm development. Updrafts are rising currents consisting of warm, moist air. These updrafts supply the necessary moisture and energy for thunderstorm formation and sustenance. Downdrafts, conversely, are sinking currents of cool, dry air. Downdrafts are often associated with precipitation within the storm. The interaction between updrafts and downdrafts dictates the intensity and life cycle of a thunderstorm. Thunderstorms involve the collision of ice crystals and hailstones. These collisions result in the separation of electrical charges. Positive charges tend to accumulate at the top of the thunderstorm cloud. Negative charges concentrate at the bottom of the storm cloud. This separation of charge creates a strong electrical field within the storm. The accumulated charge difference can eventually lead to a lightning discharge. Lightning is an electrical discharge caused by a large electrical potential difference. This potential builds between positive and negative charge regions. The discharge can occur within a cloud, between clouds, or between a cloud and the ground. Lightning serves as a mechanism to neutralize charge imbalances in the atmosphere. Thunder is a sound event associated with lightning. It is produced by the rapid heating of air around a lightning channel. Lightning rapidly heats the air to extreme temperatures. This extreme heating causes the air to expand rapidly and violently. The rapid expansion creates a shock wave that propagates outward. This shock wave is perceived as thunder. Thunderstorms dissipate when their source of warm, moist air is disrupted. Downdrafts can become dominant within the storm. Dominant downdrafts suppress the updrafts that fuel the storm. This suppression weakens the thunderstorm, leading to its dissipation.